This video provides a high-level architectural overview of the WebGrapher platform, focusing on service responsibilities and communication patterns. The WebGrapher platform consists of a series of microservices, each with a single responsibility. The crawler microservice is responsible for deciding if a web page can be crawled. Communication is orchestrated through an event bus, and microservices subscribe to or publish events to the bus. The crawler microservice subscribes to crawl events on the bus. Once an event is received, it checks the robots.txt policy of the website being crawled for permission to access the site. It also dynamically adjusts to any rate limiting restrictions imposed by the site servers. If it decides the site can be crawled, it publishes a scrape event to the bus. The scraper microservice is responsible for reading data from crawled pages, and it subscribes to scrape events on the bus. Once an event is received, it scrapes the web page using defensive programming techniques to ensure the data is safe and valid. After scraping the data, it publishes a normalization event to the bus. The normalization microservice is responsible for converting scraped data into a clean, structured format the platform can understand. It subscribes to normalization events, and once an event is received, it fetches the page from the cache and condenses the content into searchable keywords while extracting text, images, and hyperlinks that may be crawled in future cycles. Once completed, it then publishes a graph event to the bus. The graphing microservice is responsible for discovering and mapping relationships in the data. The service subscribes to graph events on the bus, and once an event is received, it translates web pages into nodes and hyperlinks into edges and stores the data in the graph database. Discovered edges can trigger new crawl events, creating a recursive event-driven loop through the pipeline. A stream event is published to the bus whenever new nodes and edges are discovered. The streaming microservice is responsible for delivering newly discovered nodes and edges to clients in real time. It subscribes to stream events, and once received, it streams a payload of nodes and edges to client viewers for interactive visualization. The client single page application, or SPA, is the user interface of the entire system. It communicates with the graphing microservice via an API and receives live data streams from the streaming microservice via a hub. Users can create, explore, and interactively visualize data in real time directly in the browser. It's important to understand that the microservices operate completely independently and unaware of each other, allowing the entire system to remain fully asynchronous, scalable, and loosely coupled. Each service can independently scale on metrics such as the number of events queued in the bus or memory and processor usage. If a service fails, the other services continue to function and process events without interruption. Events for the failed service will build up in the event bus until the service is back online. Once a service is restored, it will resume processing events from the bus. The platform's architecture allows the services to be distributed across multiple geographic regions in the cloud, providing virtually limitless scalability while ensuring high availability.